All right, everyone, we are back and we are about to do our question one for exam one. So we're going to be working with the following data sets. So let's go ahead and let's open up our, let's take a peek at our R code here. We'll do a new file for our, I don't want that, I just want a new script. New R script. So let's go ahead and read in tidyverse. Let's read in stats. And I think that's pretty much all we need for now. So, but let's also pull in from our downloads here. Let's pull in these data sets and let's put them into our documents. Q1234. And let's go ahead and let's go to our files. Let's go home. Let's set this as our working directory. And let's go ahead and let's read in those files. Here we go. So I'm going to do Q1 goes to read.csv. Again, on an exam, you could use whatever you want, but I would definitely suggest starting to again, using R would be very, very, very helpful for your exam. Read.csv, q2.csv, and then q3, read.csv, q3.csv. All right, so what are we working with here? Following data sets, which contain measurements of flow rates and liters per second of runoff pipes. Calculate 99% confidence interval, 90, 95. So we hopefully know how to do that. So we can do this multiple ways. But, again, let's try to do this the most efficient way possible. So first of all, let's look at what Q1 looks like. So we have a column. So let's just pull out Q1 bracket bracket 2, the second column here. And we can do t.test. And then we can do, let's set our confidence level to 0.90. Let's go ahead and do, let's do alternative 2.cited, and then let's set our mu equal to 1. And we can control enter that, and this would be our 90% confidence interval. So we can do that for 90. We can do, oops. So let's go ahead and do boom, boom. And then I'm going to just change this to 95, 99. So we can get this, then this, and this. Makes sense. And then I could just copy the whole thing and get the same interval there. So if I have the data set, I could really utilize R significantly. So I'm going to use 2, 3, 3, 3. Make sure, again, I will be checking on an exam like your code. So I would just try to make sure that it works for sure. And you can see the value here on that set, and then for 3, and then done. And there you go. You got your data set right there. So that is questions here, here, and here answered very, very quickly. Again, if you're using R. If you're trying to do that by hand, again, it's going to take quite a bit longer. So always be aware of that. Be cognizant of your time and make sure that you can solve those quite well. So let's go on to the next one. I'm playing with a deck of cards. What is the probability that I pull a black jack or a black card? So we want to go way back to our probability information. So this is an OR probability, so we're going to be adding, but the question that we have to ask ourselves is this a conditional, or excuse me, a mutually exclusive or not mutually exclusive event? I.e., can I satisfy the relationship here basically, are they mutually exclusive or are they not mutually exclusive? So can I satisfy a condition by pulling essentially, one of the cards? And here, a blackjack is indeed, so we're not mutually exclusive. So the probability of AUB is going to be equal to probability of A plus probability of B minus probability of A and B happening. So let's set A to be the blackjack. So we know that there are two blackjacks. So I'm going to have probability of A is going to be 2 over 52 plus the probability that a black card is a half minus the probability that I pull a card that is basically black or a jack, or that is basically, a blackjack and it is a black card, is just going to be how many blackjacks do we have? So, or what is the probability that I can pull a card that is simultaneously both black and a jack? It's also going to be this 2 over 52. So, we got that. So, our probability will just be a half here. Excellent. Now, I have a bag that has 17 blue balls, 4 red balls, and 21 green balls. I pull out the ball from the bag, and I don't replace it. So, I pull out a single ball from the bag and don't replace it. And the next 3 balls that pulled are all green. What is the probability that the first ball pulled is also green? So, there's multiple outcomes. So, it could be, there's the probability that the first ball that was pulled is green. I could also have probability 2 that it is red. I could also have probability 3 that it is blue. So I'm going to have to use, or it'd be advantageous to use Bayes' theorem here. So I'm going to look at the probability, and then we're given, they'll replace it. So we're given A, which is, our A event is, we pull 3 balls that are all green. So that is our given information, essentially, in this problem statement. So now we need to build up our Bayes' theorem formalism. So let's go ahead and write it out in full, and then we'll kind of tackle it. So we're going to have the probability of B1 given A has occurred equals probability of B1 times probability of A given B1 has occurred, over probability of B1 times probability of basically A given B1 has occurred plus probability of B2 event happening given times the probability that A given that B2 has occurred plus probability of B3 times probability of A given that B3 has occurred. All right, so let's look at what is the probability that the first ball is green. So my probability of B1 is going to be equal to, and I'm going to actually, let's go ahead and list this in R. So let's go ahead and go over here. So my probability B1 is going to be equal to, B1 is green, so 21 divided by 17 plus 4 plus 21. So I got that. Probability of B2, that I'm red, is going to be 4 divided by 17 plus 4 plus 21. Probability B3 is going to be probability that we are blue, so 17 divided by 17 plus 4 plus 21. All right. Whew. Good. Now, that's good, and that's taken care of. So we've got those out of the way here. But we're also going to have to kind of basically deal with what is the probability, excuse me, go up here, probability of A given that B1, that has occurred. So, PA B1. So, what is the probability that given that ball is, that the other 3 balls are green? So, let's start to go and calculate this one. So, we can go ahead and calculate that. Let's go ahead. And so, the probability that given the first ball, the next 3 balls pulled are all green as well. So, let's go ahead and calculate that out. So, we are going to do, it's going to be this total, but that total is going to change. So, given that the first ball is green, so we're going to do, and let's actually get this as like a tote. I'm going to call this a variable tote. Probably should have done it initially. So I'm just going to put that tote. So it's going to be, so basically we pulled 1, so now I'm 16 divided by my tote minus 1 times, and we're going to just multiply this out. So 3 events. So this times this times this. So again, we pull it again. It's basically that probability decreases one more time, and then 14. And we need to decrease each time. Tote minus 2, tote minus 3. Excellent. So the next 3 pulls are that. So let's do the same thing, and actually let's enter. The probability 2 is that the first one was red. So for red, so we pulled the red, so now we have 3 over tote minus 1, then 2, and then 1. And then, there we go. And then PA, we'll just copy that. PAB3 is going to be equal to green. So now that we're green, excuse me. So we need to do 21 here. Or actually, excuse me. We're going to do, so we were 21. The first one was pulled, so 20, 19, 18. Good news is that one's the correct below. Boom, boom, boom. There we go. All right. So now we can just put it all in to our values here. Excuse me. So let's go ahead and let's do, so we're going to do PB1 times PAB1 divided by this same one divided by this plus PB2 times PAB2 plus PB3 times PB3. And there you go. That's the probability that the first ball pulled is also green. There we got it. All right. That is problem 1. So again, there's going to be some mix of these kind of confidence intervals, small size, large sizes. When you're asking for the intervals, I'm asking for the measurand x. So we got to make sure that we get that correctly done. So that is it. Make sure you know about some of the probabilities, Bayes' theorem, mutually exclusive, not mutually exclusive. Ooh, I didn't finish the problem. Excuse me here. What about the probability of pulling a red queen or a clover? So the probability of a red queen, so that's a, so this is a not mutually exclusive bit because the clover is black card. So now we can actually go ahead. They are not mutually exclusive. So I can just do A and B equals probability of A plus probability of B, because it's an OR. So what's the probability of a red queen? There's only 2 red queens, 2 over 52, plus clover. There's 13 out of 52, a fourth. So that'd be your answer. We got it. 15 over 52. So we'll see you all in the next video, and we're going to get into normal distributions and confidence intervals. So we'll see you in the next one. Thanks.